Algebra 2, set 93, the discriminant. Okay, so just as a review, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And when you have problems that you're solving using the quadratic formula, there are three types of solutions. You can have a single real number, you can have two different real numbers, or you can have two different complex numbers. The part that's under the square root, b squared minus 4ac, is called the discriminant. So the discriminant is so named because it discriminates between the possible types of answers. So when we look at that, the possible kinds of answers, like we just said, there are three possibilities. And when you're under the square root, you can have a positive number, or you can have a negative number, or you can have 0. And those are going to define the three types of answers. So let's do an example. These examples are going to show the three different types of answers. So in the first one, we have a quadratic formula, or we have a quadratic equation. We're going to use the quadratic formula to solve it. So a equals 1, b equals 4, and c equals 4. Opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2a. So when we simplify this, negative 4 divided by 2 is negative 2, and then 4 squared minus 4 times 4 is going to be 0, and that's all over 2. Or over 2. We'll come back to that in just a minute. For the second equation, we have a is 1, b is 5, and c is negative 1. So we have opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then we get negative 5 plus or minus the square root of 29 all over 2. Now I'm assuming you're comfortable with the quadratic formula. You've used it before, you've used it several times. That's why I'm kind of rushing through it. So this is negative 5 halves plus or minus the square root of 29 over 2. And in our last example, a equals 1, b equals 5, c equals 7. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we get opposite of 5, negative 5 plus or minus. Now we have 25 minus 28 all over 2. So 25 minus 28 is going to be negative 3. So we have negative 5 over 2 plus or minus the square root of negative 3 over 2. Now to simplify that a little bit further, well actually let's go back to the original problem and then we'll talk about each individual problem together. So negative 2 plus or minus the square root of 0 over 2. Square root of 0 is 0. 0 over anything is 0. So really what we have is negative 2 plus or minus 0. And if you add 0 or subtract 0, you're still going to get negative 2. So this is one real solution. Okay, if we look at the next example, it's obvious we've got a real solution, but there are two of them because of the plus or minus. And then that third one, we have a square root of a negative number. So when we simplify that out, we get an imaginary number. And so in this case, you have two complex solutions. So when you're dealing with b squared minus 4ac, the three possibilities are that it is 0, positive, or negative. When it is 0, it is always one real number, one real solution. If it's positive, you'll have two real solutions. And if it is negative, you will have two complex solutions because you will always have the square root of a negative number. Now, for the two real and the two complex solutions, they're going to be conjugates in each case. You're going to have b squared opposite of b plus or minus whatever is in the square root. So, and then all over the same thing. So just remember those are conjugates of each other. So we'll do an example. What kind of solution does this have? You don't have to solve it, but you do have to put it in standard form. So we get x squared plus 4x minus 2. It should have an equals 0 here. A is 1, b is 4, c is negative 2. We just need to find b squared minus 4ac. We don't need anything other than that. So b squared is 16 minus 4 times 1 times negative 2. So we get 16 plus 8, which is 24. This is a positive number. So since it's positive, we know we have two real solutions that are conjugates. You don't necessarily need the conjugate part. You can just say two real solutions. Okay, next example. What kind of roots does the equation negative 2x equals negative 3x squared minus 8 have? Don't solve. So again, we're just looking for a, b, and c. So in order to do that, we need to put this in the correct form, standard form. So we have negative 3x squared plus 2x minus 8 equals 0. Figure out a, b, and c. And then we just need b squared minus 4ac. So we get 4 minus 4 times negative 3 times negative 8. Negative times negative times negative, we know it's going to be negative, so we have 4 minus, and then 12 times 8 is 96. So 4 minus 96 is negative 92. Negative number, so we know that we have two complex solutions because we have a square root of a negative number under using the quadratic formula.